Okay, folks, we're going to move on to a new property in 4.4. Basically, it's not necessarily a property, more so a skill, and it's how do we find the area bound between two different curves on the coordinate plane. And I tried giving a good visual here of that process. One of two situations can happen. You can have two different functions that actually come and then meet again, and then that creates a region that's bounded between the two curves. Or you can have one curve that just doesn't come into contact with another curve, and you want the region from two different values, from an interval, so to speak. Excuse me. So from A to B, either way, you're going to basically try and figure out the area A that I highlighted in these two situations. And it's not that difficult to kind of guess where we're going with. I mean, if we took the area underneath F, the entire area underneath F, but then subtracted the area underneath G, we would have this equation here, which gives us A, which would be the one that's kind of above G but below F. Or you can just take the integral of the difference of those two. The same is true for here. The only minor specification is A and B are now a little bit more important because they are actually intersection points between the two curves rather than like given intervals A to B. Okay? Now, either way, though, I want to specify one very important distinction. It's the upper function minus the lower function. So this is where graphing knowledge comes in very useful. And you're lucky that with remote education, I can't really deny you a graphing utensil. So moving forward, I'm going to kind of just be under the assumption that you guys have graphing calculators to your access. And you'll always be able to understand, well, okay, here's my upper function. That's going to go first, minus g of x, my lower function. And again, either one of these notations is fine. I suspect more students are going to use this one because then you only have one integral rather than two. So let's see an example at work. If you guys haven't noticed, I've been getting a little bit better with writing out everything ahead of time and then hiding everything. So we want the area of the region bounded by f of x and g of x, and they're both given to us. F of x is the linear equation 2x plus 1. G of x is a quadratic equation x squared plus 1. Now notice they did not give us an interval to integrate on, which means the wording here is kind of alluding to the fact that these two functions are going to intersect. So the first thing you want to do is consider what the graph of these two functions look like. So of course we have a linear slope or a positively sloped linear equation. We have an upward facing quadratic. They intersect once and twice here, and that contains some area in between the two, this little sliver of space right here, A. That's what I want to find the area of. Okay, it's important to note here the upper function is f of x. So when I set up my integral, it's going to be f of x minus g of x. Okay, so now what we need is we need these two intersection points because those x coordinates of these 2 points, those are going to be my a and b. Those are going to be my limits on the integral, right? My upper and lower limit. So what we have is a process to find those. So we need the intersection points. Basically, you're setting the functions equal to each other. This is nothing new. This is a nice refresher from Algebra 2. It's a refresher from math analysis. If we want points of intersection, you set the equations equal to each other to find out exactly where the graphs are at the same location. So set them equal to each other and then solve that equation. This one came out pretty nicely. We have two solutions, which is graphically kind of where you already knew there were two solutions. X equals 0 and x equals 2. The smaller of those values is going to be your A. The larger of those values is going to be B. Now, we now have an upper function, a lower function, a interval that we're integrating. So finally, we can now go and set up that integral. So it's the integral from 0 to 2 of my f of x minus g of x, okay? And that I simplified inside first just to distribute the negative combined like terms. Take an antiderivative, which we are getting very good at by now, and plug in your upper and lower limit and evaluate your difference. Your final answer, 4/3. Now, that means this area here has a value of 4/3. Now, eventually we're going to start kind of learning a little bit more significance of this, but it's kind of nice to know we have a process of getting area of all these funky shapes now, even between two curves. Seeing as it's Friday, seeing as you guys had 2 very long weeks of remote learning, I'm going to chop it there and only include the one example. The homework that I assigned for this chapter, we're going to make that due probably middle of next week, because there's 1 or 2 big examples I want to get through in this chapter before moving, or in this section before moving on. So happy Friday, enjoy the weekend, and I will touch back base on Monday.